All right, welcome to day six, week six, day one. We're going to go over the AWS AI practitioner, and we're also going to teach you some AI fundamentals to go along with it. So, as I was saying before, we're essentially following the same premise as last week, where we're going to go over the concept of the test, go over some basic AI, ask some questions in between, and then cut you guys loose to do some self-assessments. So, to get started, we're going to do the overview. This is going to look really familiar. It's essentially the same as the cloud practitioner. So some things you can do to ensure that you'll pass is you could attend these lectures. Make sure you understand AI, ML, and Gen AI vocabulary, which we're going to cover. Do the practice exams. Try to do the one a day. Focus on use cases. It's a lot of like just taking the services that exist and then solving a business problem with it. And then take advantage of all the free stuff that we're showing you guys in the resources. And then for the time commitment, if you're a total beginner, it should take about 30 study hours. If you're experienced, about 6. The average student's about 24. And remember, there's going to be overlap from that cloud practitioner. So it may be less study time than what you're, I guess what's normally expected. The only thing I would say is if you do have the cloud prac stuff down, then focus more on the AI because it does overlap, but you still have to know all the AI stuff. You can split your time evenly between lectures and guided content and the actual practitioner exams, self-assessments. And just like the cloud prac, it's 65 questions. There's 50 that are scored and 15 that are unscored. You have a total of 90 minutes to complete it, and you should expect about 120 minutes, 2 hours for the actual check-in process and getting everything set up. It has the same passing requirement, which is 700 out of 1,000, 70%, and your cert will be valid for 3 years. So to get the ball rolling, we're going to just start with some random guessing, as we do. Question 1. Which AWS service provides a simple way to use foundational models for various providers via API? Does anyone have a guess?
AWS service provides a
Bedrock.
simple way to
SageMaker?
use foundational models.
Somebody said something? What?
Did Bedrock. SageMaker? I don't know if
SageMakers?
that's via API.
I
I've
think it
used it in the
is.
console
Yeah,
before.
it is SageMaker. Because
I was gonna say
Ooh,
Bedrock.
SageMaker
bad beat.
recognize.
So this one you're using foundational models. Bedrock is like a lot of more if you're utilizing the agent, and SageMaker is more if you need to train your own model.
I guess that's why I'm more familiar with it.
Okay, right on.
Mhm.
But that's a solid guess. It wasn't completely left field. Question 2. A company wants to add image and video analysis to its application to detect objects. Which AWS service should it use?
Recognition.
Recognition, let's see. Solid. You can remember that because the AI needs to recognize the image and videos or whatever content is there. Question 3. What is the pillar of responsible AI that focuses on ensuring a model's predictions? Oh, excuse me. That focuses on ensuring a model's predictions can be understood by humans.
Interpretability.
Transparency.
Which ones did you say?
Transparency.
And someone said what else?
Interpretability.
That was really close. The second one was
Explainability.
close. Explainability. So I don't know if everyone's reading ahead or if you guys are just super sharp, but you guys are really good. So next lesson here, or the first real lesson. So intro to AI, we're not deep diving, right? We're just going to hit the surface of what the expectation should be that match, the cert. So first question is, what is AI? The definition is it's a branch of computer science that's focused on building systems that can perform tasks that typically require human intelligence. So it's essentially getting a computer or machine to do something that they normally couldn't. The expectations that us humans could do, though. So what does that actually mean? Another way to look at it is to compare AI to a human brain. You could think about how it tries to learn and make decisions. That's a big thing, is the decision making. AI, in a way, mimics aspects of the human brain. I want to emphasize it's more of the aspects of the human brain opposed to the human brain itself. One big example is when we get to deep learning. Deep learning uses neural nets, and it's essentially designed in the image, if you would, of neurons, of how neurons work in the human brain. So in a sense, it's kind of created on the basis of like biomimicry, but it's just once again would be more of an aspect of the brain opposed to how our brains actually fully function. So here, AI does not replicate. Oh, that's pretty much what I said. It doesn't replicate the brain or its full capacity, just like a portion of it. One of the biggest things that it doesn't do, especially here, is the consciousness. So kind of remember, no matter how impressive AI seems, it's really just math, and there's no consciousness involved with it, unless you want to make an argument of what our consciousness is, but that's a whole conversation. So how does AWS specifically define it? You'll notice that it's 99% of the standard definition, but I'll read it again for emphasis. It's a field of computer science dedicated to developing computer systems that can perform tasks that normally require human intelligence. So they're both essentially the same, but I felt it was important to include both. Some of the key concepts that you do need to know for this test, and this is just for AI as well, is what a model is. You can think of a model as the brain that results from the machine learning training process. And then training refers to the process of teaching a model by feeding it data. So essentially, the model is literally just a bunch of functions, you can kind of think of them as, that interpret data to a certain extent. And if that interpretation is what the humans, right, the creators of this model deem appropriate, which is really just like kind of like how close was it to our expectations is really all that is, then the model's fully trained and then they'll release that model. If you have a model that already exists, that's trained, that other people have access to, you can fine tune that model. And then it will take that pre-trained model and it's going to now have a specific task. So a lot of the instances of AI that you see all these big AI companies, all they're really doing are taking pre-trained models. They're taking like Anthropic and like Google Gemini, all of their hard work, all of those hard models, and then they're just fine-tuning it to give it specific tasks that make it seem more specialized in one particular area. Whenever you have that product, no matter what it is, that fine-tuned product or even a raw model, you're going to give it a prompt. The prompt is usually text. So whenever you interact with Gemini, ChatGPT, whatever, when you're typing in whatever, hey, how do I do this? How do I do that? That's the prompt. And what it does is when we give it to the model, it's going to generate a response. So it's not just like pulling it from a database. It's like, generating, it's creating its own interpretation of what the answer is. And then there's inference. That's the process of using a trained model, so once again, the same trained model, to make a prediction or generate content. So it's essentially, this is the output that we were referring to. The prompt input, inference is the output. Does this portion make sense to everyone? All right, I assume that's a yes. So how does AI work? AI starts with data input. This is essentially what they're trained on, is data. This can be different forms, text, image, audio, video, etc. So with machine learning algorithms, it's mostly going to be text. But here it's machine learning algorithms. They're mathematical rules and procedures that allow computers to learn patterns from data and are used to train the computer from a given set. So essentially this pattern recognition, it's like it takes the data, it recognizes patterns, and then when the humans say, oh, you know what? Your ability to create that pattern is really good, you are now trained. That's essentially how it works. And if that pattern, the output is not what is expected, then there's things that the humans will adjust until the model has that desired pattern or close to it. And then a machine learning model, what you get after the learning is done, right? So the model, it's already now finalized, it's been trained. It's actually what makes the predictions or decisions based on the data. Once it's trained, the model can be used to make predictions based off of new or unseen data. And this is the most important. That way it's not just like regurgitating stuff or what they would call like overfitting. I don't remember if we're going to hit that today. But essentially, a machine learning model, when it's trained, sometimes if it gets trained so well off of the training data, it's not better. It's actually worse because it becomes so good at just the training data, it can't create those patterns or recognize the patterns in anything else. So just a little fun fact that we may or may not get into today. I don't remember what's coming up. So as you already know, AI is the field of getting the computers to do something that normally humans can do. But it's also made of subfields. The subfields are machine learning, deep learning, and generative AI. And then here's just a cool visual for you. It's the same thing we just said. And then other subfields, which I think we just touched on today, is natural language processing, robotics, computer vision, and that et cetera is not too helpful. But there are more subfields, but these ones, this is essentially the main ones. All right, I'm going to pass the buck a little bit. Can somebody read this first portion about what machine learning is?
Machine learning is a branch of artificial intelligence that focuses on enabling computers to learn from data and make decisions or predictions without being explicitly programmed for every specific task. In simple terms, machine learning uses algorithms to find patterns in data. However, traditional machine learning often requires humans to manually identify and extract the important features from the data, called feature engineering. For example, to detect spam emails, a human would need to tell the machine learning model to look at specific things like number of exclamation marks, presence of certain words, or sender reputation. So, for example, spam filters, recommendation systems, and fraud detection.
Cool. And can somebody read deep learning?
A subfield of machine learning that uses artificial neural networks with many layers to learn from large amounts of data, especially complex data like images, audio, or text. In simple terms, deep learning can automatically discover what features matter in raw data without human guidance. Instead of a human telling it what to look for, deep learning models figure it out themselves by processing data through multiple layers of artificial neurons. This makes it much more powerful for complex tasks like understanding images, speech, or language. Examples: image recognition, voice assistance, language translation, generative AI. Key differences: traditional ML requires humans to identify important features in the data. Deep learning automatically learns these features on its own from raw data.
Thank you. Can somebody, in their own words, tell me the difference between machine learning and deep learning?
Machine learning is using computer algorithms to find patterns in data, but they require human intervention to tell them what patterns matter. Deep learning does all that, except it can find the patterns automatically without as much intervention from a human.
Okay, your answer is not wrong, and that is a solid self-worded response. So you get credit.
Deep learning, it falls within machine learning, right? It's a subset of it, right?
Correct, but what's the difference still? Well, they're both technically more specifically, they are more subsets of AI in general, but you are correct. Deep learning is, in a sense, a subset of machine learning. But aside from that, what would the difference be between the two, in your own words?
I mean, it just includes neural networks generally.
I'm sorry, I couldn't hear you.
So sorry, that's just deep learning typically includes neural networks.
Correct. So
So
yeah, that's one of the differences as well. So that answer also gets the credit. So far, there's been no wrong answers.
and yet I feel like you're asking for more.
Well, actually, I was just kind of more curious to see what the class can come up with their own distinguishment.
Yeah,
Um,
I just generally, I mean, for deep learning, it's more of a black box, right? So, like machine learning, there's set algorithms that are kind of standardized mathematical formulas that can be traced, I would say. And then deep learning, it's the system is determining what are the correct algorithms to use, kind of based on, which neurons are making the correct guesses. So it's kind of a, yeah, I would just say like more of a black box that way because it's determining what's the best method to get the answer.
Okay. Yeah, and that's also credit. So yeah, so far all solid answers. Were there any additional perspectives of the difference, or do you feel like between those three answers that were provided that as a class we've identified the difference between the two?
Yeah, I think that sums it up, except for the complexity.
What do you mean
Deep,
by except for the complexity?
uh, because with machine learning, the algorithms are pretty basic uh compared to a deep learning. So I know deep learning, as was previously stated, uses a neural network to perform its computations, and those computations are usually like very complex though, because I know there's a thing, and it's because I know within the field itself of AI, they're trying to move to the point where not all the nodes within a neural network actually activate, so it more along the lines mimics an actual neuron, where only certain neurons activate. So that requires a lot of computations. Like I know with the machine learning algorithms, though, sometimes I mean you have like a linear algorithm, even a kernel type algorithm, or even some more complex algorithms, but it still doesn't match the same complexity as a neural network, though. Because I mean, you could have like multiple, if not like millions of nodes performing parallel computations, and that requires GPUs instead of CPUs, or G. And actually, there's a different kind of they're now designing a new type of chip specifically for deep learning. It's like an NPC or something like that.
Oh, that's cool. I'm not familiar with a new chip specifically for it,
And
um,
it,
but I'll definitely look that
um,
up. And everything else you said is also correct. So
yeah,
far, every answer that everyone has given is correct. So once again, yeah, so that was the intent of the question was kind of to see what would your perspective be? What is your answer? Because it's to me, I don't think it's such a simple answer, but there's a lot of simple answers that are correct because it's kind of like a multifaceted answer. And I'd say even if you wanted to give a very basic answer, is the output. What's the difference? Oh, well, the output, right? The When you say complexity, in terms of functionality, right, of the functions that are being used to train the data and that's being used to recognize the patterns, that's a great answer. But then even just in the sense of just complexity of the use case, right? Like you wouldn't use deep learning for basic like chat and response. Like when's my birthday? Or I guess I don't know, what's a simple question people ask? What should I do with
What's
my
the
life?
weather today?
Yeah, what's the weather?
Yeah.
Exactly. But yeah, every answer is absolutely correct. So great job. I could tell that everyone's, you know, been studying outside of just what we're doing here. So solid. There's one more. Generative AI. I'll go ahead and read this. It's a type of artificial intelligence that can create new content such as text, images, music, code, video, and more. That's similar to what humans might produce. In simple terms, generative AI is a type of deep learning focused on creating new plausible content, not just classifying data. So generative AI, you've seen it everywhere. Everyone knows about AI music, or if you've used Lovable to create an app, or using Copilot to help with code, whatever. So it's essentially utilizing the complexity of deep learning now to generate something more complex, right? Generating, to kind of clarify what we were saying before about the differences, there's no real way to train a model to generate such abstract and open-ended outputs. And that's kind of where that deep learning comes in, because it's not now just, oh, let's take the most basic recognizing pattern, which is essentially looking at data and trying to come up with a label, which is the Y label of saying, oh, this is a cat or a dog. That's essentially machine learning. And in deep learning's now that more of this open-ended saying, hey, I'm going to figure out the question and the answer sort of deal. So how did we get here? The evolution of AI. It started with symbolic AI, which is rule-based. That was great for a specific logical task like a calculator. But it's brittle and it can't handle uncertainty. You can think of symbolic AI as like if-then statements. A good example, an old example would be, was it Deep Blue by IBM, which was their chess playing computer. Essentially what it did is it just had like a set of patterns, like moves and such, but it was literally like, if the opponent did this, then I'll do that sort of deal. So, I mean, it's pretty cool, but it doesn't compare to, what we're actually doing today. Then there's machine learning statistical, and that's because machine learning has been around forever. So statistical, better at finding patterns in data, such as spam filters, but require feature engineering. Then there's deep learning with the neural networks. This can learn complex patterns directly from raw data, like images or text, powering the current revolution. So yeah, so I hope one of the biggest things that you take away with the deep learning is that it doesn't need to be like handheld, I think is a good way to kind of think of it. With machine learning, it needs the data, it needs to be told what to identify, and then through whether it's like regression or classification, it's either going to cluster or use some form of math. There's different formulas that it's going to use to try to group things together essentially, or divide things depending on what you're trying to accomplish. And deep learning is just kind of like, oh, hey, I'll figure out what this is, and like leave me alone sort of deal. All right, and then there's generative AI, which we've talked about, which is a type of learning focused on creating new plausible content, not just classifying data. So there is some vocabulary that you should know. We're not going to talk about it right now. A lot of this will be throughout the week, some today. But you should know supervised versus unsupervised learning. That's a part of training. Classification versus regression. That deals with the type of data that it's being trained with. Essentially, if it's classes or real numbers, that's an easy way to remember that. Foundational models and large language models. Responsible AI, fairness, explainability, and bias. You're going to cover this a lot on Saturday. In fact, Saturday is just about, I forget what they call them. There's like 5 sections of the test. The 5th section is going to be on our Saturday. And then you should know SageMaker, Bedrock, and Recognition. You're going to go over this in detail, but SageMaker is to train your own model. Bedrock is to use agents with existing models. And then Recognition recognizes, right? It sees in a way like text and words and images. And then the exam will ask things like, a company needs to analyze customer reviews for sentiment. Which service should they use? We use Amazon Comprehend, which we haven't covered yet, but it will get covered. Which term describes training a model on data that has correct labels? Supervised learning. Since this example is here, a label is essentially a desired output in a sense. You can kind of think of it like that. Where we'll go back to the cat dog analysis. Let's say you have 100 pictures of cats and dogs, and each of those pictures are labeled with either cat or dog. And then you train a model on these 100 pictures. What it can do is it will then look at each picture and say, oh, this picture is a cat, this picture is a dog. It's going off of features, so it's not really it's not really looking at the image, but that's past the scope of this, this class. But essentially, it's looking at these images and it's then recognizing based on because they're labeled. It'll say, oh, this is a cat, this is a dog. I'm understanding. So then once it's trained, then you can give it a picture of a cat or a dog, and then it can say, hey, that is a cat or a dog. In theory, there's always going to be some level of error. But if that was the case, it's supervised. Supervised has the answer for them to be trained on. Unsupervised is if you gave it 100 pictures of cats or dogs without the label. And now part of the training is it needs to figure out which one's a cat or which one's a dog, merely based on it's really math, really based on math. And then if it got trained unsupervised, so most trained models are actually going to be supervised, especially if they're dealing with classification, cat or dog, this or that. All right, so practice questions. Question number 1. What is the process called when using a trained model to make a prediction? And
Tuning?
I'm sorry?
Fine tuning?
Fine tuning. You believe fine tuning is the process of using a
I don't
trained
know.
model to make a prediction?
Oh,
So
no.
supervised learning.
Say again?
Supervised learning.
All right, we got 2 answers. Inference. Now remember, it's okay that you guys don't know this. Guessing is the fun part. And it also helps you, get your brain working and just making connections. So yeah, if it infers something, it's the process using a trained model to make a prediction. If you're predicting, you're inferring. So it's called inference in AI terms. Question 2, what type of AI creates new content, like text, images, or code?
Generative AI.
Yep. What is the key difference between traditional machine learning and deep learning?
Machine learning requires
Simple
hu-
algorithms, while deep learning requires more complex algorithms. Is the computation. Both require data, of course. Both require a lot of data.
the
Different
term for when people tell them whether or not it's the right answer. Feature
prompting,
something.
feature extraction, or feature engineering. Is that what you're referring to?
I don't know. Let's see what the answer is.
All right, let's see what the answer is. Traditional machine
Feature
learning
engineering.
requires manual feature engineering, while deep learning automatically learns features from raw data. So remember, this question's open-ended because as we discovered before and we've talked about, there's kind of a lot of differences and a lot of ways to present those differences. On the exam, they're not going to straight up ask you, hey, what's the difference? Especially with such an open-ended aspect. But here, just one way to look at it, and you called it out, is that traditional machine learning requires feature engineering. Deep learning automatically learns features from the raw data. Question 4. What is the brain, in quotes, that results from machine learning training process?
Are you just wanting us to call it out? You want us to raise our hand?
Oh, okay, just heads up. I don't know if you guys know this. I don't know if it's just like my setup. When I'm like recording and screen sharing, I don't even see anybody.
Okay.
I'm literally just listening. So yeah, if you guys have been raising your hand or even writing in the chat, don't think I've been ignoring you. But yeah, just call things out.
Model.
Model.
Learning
Yep,
model.
perfect. Question 5. What is the process of adapting a pre-trained model to a new specific task?
My first answer.
Yes.
Fine tuning.
Does everybody agree?
Yes.
All right.
Indubitably.
All right, good job. All right, so summary, you now understand what AWS exam expects from you, more or less. The core definitions of AI, ML, and generative AI, how AI has evolved from simple rules to complex models. Intro to AI, use cases. So here we're going to just kind of talk about use cases, not necessarily referring them back to the AWS service. And in the next portion, we're going to go over the services. So for this, I'll read one and then we'll kind of pass the buck because there's a few of these. Okay, so where's AI used? Essentially, the answer, you're going to know it's everywhere, especially, right? It's every day, it's even more places. But here, let's see if it's anything significant. It just says from your phone, unlocking your phone with facial recognition, receiving personalized recommendations while shopping online. At work, behind the scenes, yes, it's everywhere. So here are some more everyday examples. Your virtual assistants, Voice-based assistants like Siri, Alexa, Google Assistant. They understand spoken language and they respond intelligently. I think this should have an asterisk on it. They can set reminders, answer questions. You guys use virtual assistants. Recommendation systems. So when you're using Netflix and they say, oh, if you like this show, you'll like that. When you're on Amazon and you're buying something, it's like, oh, do you want to add this to the cart? I mean, all of that is part of AI. Image and speech recommendation. Or does it say recommendation? Yeah, it does. AI enables apps to identify faces in photos, transcribe voice recordings into text, and even unlocks phones with facial recognition. Healthcare diagnostics. In healthcare, AI helps doctors diagnose more accurately by analyzing medical images. They also detect patterns in patient data to indicate risk. One of the cool things that I learned, I don't know if you guys know this, we had mentioned symbolic AI. So I was looking up different examples of it earlier. And it was, if you remember, it's mostly like if-then statements. And initially, it was used in healthcare to help make medical decisions, which is kind of scary, I guess, because it was just super basic where it's like, oh, if the patient's this old and they have a cough, or whatever. It's just like if-then conditionals. So we've come a long way to the point where now we can analyze X-rays and actually detect patterns and indicate risk and such, which is pretty wild. Self-driving cars, autonomous vehicles use AI to interpret data from sensors and cameras. It helps them recognize the lanes, stop signs, people. Financial services, it can detect fraud. It can automate trading and offer personalized financial advice. Customer service, you guys already know about chatbots. I'm sure you've used them before, even if you don't know if you were using them. And then it can translate language. Google Translate uses AI to convert text or speech from one language to another. And then here the big picture. This essentially just says that it's used everywhere because it is. Okay, so here's like a little bit more. It's a little more interesting. So here's business problems and AI solutions. So we're going to start with number one. Can somebody read all of number one, please?
Computer
Compu-
vision, analyzing images and video. The business problem, my application needs to see. I need to find objects, people, faces, or text in photos and videos. This is one of the most common AI workloads. Use cases, content moderation, automatically flagging inappropriate or unsafe images and videos. Facial analysis, detecting faces for user verification, like unlocking your phone or counting people in a crowd. Object and scene detection, identifying items in a photo, such as products for an e-commerce site or damage on a car for an insurance claim. Text and images, OCR, extracting text from scanned documents, license plates, or street signs. Relevant AWS service, Amazon recognition is the primary service for these tasks.
Perfect. So yeah, so just essentially the TLDR is just vision, right? And just kind of seeing things and utilizing that data to solve real world business problems, such as finding, here in this example, what does it say? I need to find objects, people, faces, or text in photos. I'm curious where that's a real business problem, like in those literal words. All right. But yeah, so that's essentially computer vision. Remember, it can see, recognize in a sense. And for sure, you are going to utilize OCR in at least one project that's coming up. Actually, more of one lab once we get into more of the AI depth. For natural language processing, the business problem is if the customer says, I have a massive amount of text and audio data, and I need to understand what it means, process it, or translate it. Can someone read the use cases that relate to that business problem?
Transcription, converting audio from customer service calls or video meetings into searchable text. AWS service, Amazon Transcribe. Translation, automatically translating website content, documents, or real-time conversations. AWS service, Amazon Translate. Sentiment analysis, reading thousands of customers' reviews to understand if the overall feeling is positive, negative, or neutral. AWS service is Amazon Comprehend. Chatbots, building conversational intelligent chatbots that can answer questions or perform tasks. AWS service, Amazon Lex.
Cool. I thought the services were removed from here. I'm just gonna take a quick look. That's interesting. I don't know if they were added back by another instructor. All right. So yeah, so far we've went over two different business needs. One where computer vision can apply to all of these instances or solutions. One where natural language processing can, help with these problems here. And then can someone read for personalization and forecasting? The business problem here is I need to predict what a customer will do next or what my business needs will be in the future.
Use cases, recommendation engines, powering the customers who bought this also bought or recommended for use sections on websites like Amazon.com. AWS service, Amazon Personalize. Business forecasting, predicting future product demand, inventory needs, or website traffic based on historical data. AWS service, Amazon Forecast.
Cool. And then another business problem here is I need to create original content, summarize complex information, or build a super assistant that can answer any questions. So that can be solved with generative AI. And can someone tell us the potential use cases for that business? Sorry, they're right here.
Content creation, writing a blog post, a marketing email, or a product description. Summarization, condensing a 10-page report into a 1-paragraph summary. Conversational agent, an internal expert that can answer complex questions about company policy or technical documents. Code generation, writing software, fixing bugs, or explaining what a block of code does. Relevant AWS services, Amazon Bedrock for accessing models, Amazon Q, the AI assistant, and Amazon Code Whisperer for writing code.
Thank you. Does this portion make sense? It's essentially just saying with different problems, there's different aspects of AI, computer vision, NLP, etc., that have different use cases to solve that problem.
Hey, Jonathan,
I'm sorry?
I was just going to mention this is a really good section to remember. You'll definitely see questions like this. I saw questions like these, so.
Okay, cool. Yeah, thanks. Yeah, and if anyone got here late, Chad said that he did take the AI cert this weekend and he passed it. So if he's saying that, this model essentially is saying, hey, specific business problems with the solution, hopefully this section here could be a potential little cheat sheet as well. So we're going to do some practice questions together. And then once again, just go ahead and take a guess. Did anybody hear that or am I going crazy?
You're crazy.
Good. All right, question 1. Which AWS service would you use to extract text from scanned documents or license plates?
Extract.
Did you already know that? Oh, it was wrong. You said it and it sounded right. We are going to talk about TextRack, actually, I think in the next page. Recognition, remember recognizes? So, well, actually, is this, you know what? Hold on, let me put this one into Gemini, see if this is correct.
I would have said TextRack too.
Yeah, I feel like
recognition is
TextRack
more
sounds
like
like a better
images
answer.
and videos.
The thing is, the question isn't specifying images.
Yeah, let me
But
see.
then again, a scanned document could be interpreted as an image, so
Oh, a scanned document or license plate. Oh, yes, 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 yes. I'm asking Gemini, but yeah, exactly. This would be the key here. So this could be considered like a tricky question because if we just said extract text and then TextRack, like definitely fulfills that. But specifically if it's scanned or real life license plate, it's not actual text, right? So it has to recognize what it's seeing. And then OCR is what is it? Optical character
Character
recognition.
recognition.
Yeah. And once again, you are going to utilize that for a project that uses a PDF. So a scanned document, essentially a PDF, as someone had called out. All right, question 2. A company needs to build a conversational chatbot that can answer customer questions. Which service should they use?
Flex.
Any other guesses? All right, that one is Lex. Question 3. Which service predicts future product demand or inventory based on historical data?
Would that be SageMaker?
SageMaker, let's take a look. Forecast. So if you remember SageMaker, it already has trained model, or I'm sorry, that's Bedrock. SageMaker allows you to train your own model. So, I mean, you could make the argument that you could train your own model to forecast. But in this case, there's already a product for that, which is Amazon Forecast. Question, but solid guess still. Question 4. What type of AI involves writing blog posts, summarizing reports, or generating code? And it's not a service, just a type of AI.
Generative AI?
You got it. Question 5. A retail website needs to show customers who bought this also bought. This recommendation, what kind of AWS service would allow that to happen?
Personalize.
Any other guesses? All right, that's the answer. All right, what's here at the bottom? Let's see if this is important. Well, yeah, it's just saying that, the business problem is important. Cam also confirmed that. And he's the most recent person to take the test. So we're definitely going to listen to him. All right, here's the third portion. This one's focused more specifically on AWS services itself. So organizing the AI stack. Here, the good way to think of it is as 3 different layers, right? Layer 1 is going to be AI services, the top layer. Layer 2 is generative services, and then layer 3 is machine learning platforms. So we're going to go over this, and then at the bottom we'll talk about when to utilize it. There is a good chunk of reading here because it's essentially a list of services. But I'm going to have somebody go through and read. Can I get a volunteer to read all of these services for layer 1? Oh, and I'm sorry, actually, let me read this portion first because this is important. So layer 1, it's pre-trained, API-driven services. That's important. Pre-trained, API-driven services. You don't need any machine learning knowledge to use them. You just send your data, like an image or a block of text, to an API endpoint. And AWS sends you back the answer. These are layer 1 AI services. Can someone go ahead and start us off with vision?
Why are they organizing by layers? Because the level of complexity? Or
I think, no, well,
because
that's interesting. I guess it depends what you mean by complexity, right? Complexity is perspective. It's kind of more going to be based off of like hands-on in a sense.
Okay.
But because we have we were going to read it at the end, but I'll go ahead and read it now because that is a solid question. So the takeaway here or whatever, with layer 1, which is the AI service, always try to solve a problem with a pre-trained service, right? If it already exists, just use it, right? Recognition, comprehend. Layer 2, which is generative, that's when you would use like Bedrock to utilize the agents, or Q, when you need to create new content, summarize or build powerful, broad knowledge assistant. Then essentially, if you can't solve the problem using a pre-made service or the generative AI, then you go to layer 3, which is machine learning platform. This is SageMaker here. It says only use SageMaker when your problem is highly specialized and requires a custom-built model that you must train from scratch.
So it's the complexity of the problem.
I'm sorry?
So it's the complexity of the problem then, kind of, sort of.
The complexity of the problem.
All right, depending on how difficult the problem is, depends on the level of.
I don't know if that's a fair statement. I can get the perspective. The reason I don't know if it's fair is because the complexity of the problem doesn't necessarily relate to the complexity of the solution, right? Unless that's what you're referring to, is just the complexity of the solution.
No. I mean, I don't know. I mean, I'm trying to understand it conceptually. Just trying to understand it. This is the way I learn. I don't want to try to memorize anything. I just try to understand it.
Yeah, no,
And
that's
lo
a
and
great way to
behold,
learn. Keep asking your questions and let's keep talking. Because I don't think you're wrong. The only thing is I'm afraid that it's not a complete or it's a potential mislead. Because I feel like there's times where what you're saying is correct. So it's not like this wild, notion you threw out there. If a problem's more complex, I think it's fair to assume that the solution is more complex. And it sounds like the logic you're getting at is saying, hey, if it's more complex, you're going to have to like kind of build the solution from scratch. But if that's what you were getting at, I don't believe that's always the
no,
case.
no, no, because I think with the way you said it, it makes a lot of makes point. Because like I said, one of them, like layer one has a pre-trained model, right?
Mhm.
So I think the difference is, it just depends on the kind of solution you need. I think that's what it basically boils down to.
The layers look like they're organized by complexity for the direct user. So layer one, it's as simple as sending something to an API and it spits back an answer. Pre-built, good to go, easy. Looks like layer two is you may have to do some training, like giving it the content to train it on, but it's like a pre-built model that is going to take that content and then spit out generative AI stuff. And then layer three is the most involved by far. You're going to have to, like it says, custom build a model that you must train from scratch.
Mm,
So as you go down the layers, it just looks like it gets more and more complex for the engineer using the service.
yeah, more work.
Yeah,
Okay. Yeah,
that's
that's
what it looks like
solid.
to me.
That's solid. And then also too, just to iterate going back upwards, with SageMaker, you're training, and it just because you said one thing that was erroneous. You said with layer two, you're training. Layer two is not has nothing to do with training. So with layer three, you are training your own model. That's something that 99% of the world can't do on their own computer. Like we don't have the processing power, which is why you'd have to go through a big company like this. So layer three, you're training the model from scratch. You're creating your own model. Layer two, you're utilizing existing models, but essentially are you using
Fine-tuning it.
agents. Yeah, you're fine tuning to create your own specialization of agents is what you really should be doing. And then one is more of like kind of out of the box. It's just saying, hey, I have a PDF, for example. I need to just extract this data, or not even, yeah, just extract this data. You don't need to train your own model for that, and you don't even need an agent to do that, because then you can use Recognize to just take that information. But then, of course, you can also utilize these layers together. You can use Recognize to take the PDF and then maybe just put that content in a database, and then you can have an agent manipulate that data or whatever. Has all of this clarified or confused?
More
All right.
clarity than confusion.
Oh, that's good. That's progress. Because also to remember with, actually, I don't know if remember, I don't know if you guys discussed this. With any sort of AI, whenever you train AI, you're never going to get 100% correct. Literally all of AI, whenever they train models, it's all about reducing error. And you'll notice even like when you're creating projects and you're using like RAG systems and agents, whatever, you're still not always going to get a perfect answer. It's literally just how do you reduce error? So here, sharing this with you guys, it's like, yeah, not everything's gonna be perfect, but if more clarity than confusion, it sounds like we're reducing error. So, you know, it's a good.
Yeah, I only need a 70 to pass the test. So
That's the spirit. All right, so layer one, which we know is more of like the out of the box. Can somebody read these essential like these AI services and then the AWS service that handles that?
Vision, Amazon recognition for analyzing images and videos. Use case, object scene, face detection, content moderation, text extraction, OCR, and facial analysis. Language and NLP, Amazon Comprehend for understanding the meaning of text. Use cases, sentiment analysis, key phrase extraction, entity recognition, finding names or places, and language detection. Amazon Transcribe for converting speech to text, use cases, creating subtitles for video, transcribing customer service call, or making audio content searchable. Amazon Poly for tuning text to speech, for turning text to speech. Use cases, creating voice for mobile apps, accessibility tools, or automated voice messages. Amazon Translate for translating text between languages. Use cases, translating website, documents, or real-time chat. Document analysis, Amazon Textract for extracting text and structured data, tables, forms from documents like PDF and scanned images. Use cases automating data entry from invoices, processing loan applications, and digitizing media records. Conversational AI, Amazon Lex for building chatbots and voice assistants powered by the same tech as Alexa. Use cases, customer service bot, informational bot, and application control bot. Forecasting and personalization, Amazon Forecast for predicting future business metric. Use cases, predicting product demand, inventory needs, or future website traffic based on historical data. Amazon Personalized for creating real-time personalized user recommendation. Use cases, powering recommended for you sections on website or personalizing marketing emails.
Cool, thank you. One of the things I'm sure you already caught the pattern is that Amazon's names are like very, I don't know, very apparent, I guess, right? Like I kept saying recognize, right? Recognize, analyzes the images, it recognizes, it comprehend, understands the meaning. Transcribe, it transcriber in real life converts speech to text. Poly, I mean, not so much, but Poly want a cracker, sort of, you know. It talks, so text to speech. Amazon translates, etc. Textract is literally text extraction. So as long as you guys study, just most of these services should stick. You know, just a heads up. For layer 2, so this is where we're going to kind of like, now we're not using these out of the box services. Remember, you can use them in parallel, but layer 2, they're generative services. Does somebody want to read these 3 points for us?
This is the newest and most powerful layer focused on creating new content and handling complex Ask Me Anything tasks. Amazon Bedrock. This is the main service for generative AI. It is an API that gives you access to a wide range of foundational models, FMs, from providers like Anthropic, AI21, Stability AI, and Amazon Titan. Use cases, summarization, text generation, writing emails or reports, Q&A, and image generation. Amazon Q, a generative AI-powered assistant for businesses. It can connect your company's data, like wikis, code, and documents, to answer expert questions. Amazon Code Whisperer, a generative AI coding companion that suggests code, writes functions, and helps you program faster.
Cool. One of the things I do want to point out for layers 1 and 2, just like every other service from AWS or whatever, you can potentially do most of this stuff without AWS. It's going to either take a lot more coding or money, but it can all be done. So just like, because even like this recognition, right, OCR, you can use free OCR libraries in your code, for example. There's different like levels and quality, but you can use them. Same thing, speech to text, there's free services, a bunch of free services for that. And then what was this other one too? Oh, like here, the Amazon Q. Essentially, one of the labs I created for you guys, I think it's week 14 or 23, I forget which one it was. But I know those are 2 different weeks, but it's one of them. We're going to ingest municipal codes and then use RAG and a model to actually answer questions specifically about that code without having to like hallucinate or anything, because it's just going off of that one specific data set. So that's essentially what Amazon Q is doing, but like I created it in 3 days by myself, you know? So just a heads up, anytime there's business needs, there's always like pros and cons, like speed versus cost, but just know most of that can be done. For layer 3, this is where like most people can't do it, unless you have like a super computer, some crazy stuff. But can somebody go ahead and read out layer 3, please?
This layer is for building, training, and deploying your own custom ML models. You use this layer when the pre-trained AI services in layer 1 aren't specific enough for your unique business problem. Amazon SageMaker. This is the one service to remember for this layer. It is a massive, fully managed platform for the entire machine learning lifecycle. Use cases: building a custom fraud detection model, training a unique computer vision model for a specific manufacturing part, or having full control over your ML environment.
All right, thank you. Let me ask, is there any confusion still regarding this section? All right, let's do some practice questions together.
Hey, Jonathan, I'm sorry. May I add one additional part on this?
Of course.
Yeah, so we're all tracking like Amazon Comprehend. What you may see on the exam is something very specific to an industry, specific like healthcare. So you may or may not see something like Amazon Comprehend Medical. And just because we haven't seen it in any of the lectures or things like that, that is a thing that because there's just so many services out there. So what I'm telling you is that if you do see Amazon Comprehend Medical and you're like, I know what Comprehend is, and this question is specifically about healthcare, and if AWS had this feature for healthcare, that would be awesome. I would choose that one. I hope that makes sense. So just because we can't see it in any of these lectures, if it's in there, it might be a good option to choose.
That's pretty good advice. So pretty much what you're saying is like, don't fully just be like ML. Try to be more like deep learning, and use like context and stuff for things you don't know.
You say
Yeah,
make some
like
inferences.
Yeah,
yeah,
exactly.
yeah. Yeah, because like I studied quite a bit, but then like I saw some of these questions, these options. I was like, oh, I've never seen that before, but it makes sense. And then I came back and I Googled it. I was like, oh yeah, they actually AWS does have that service. I was like, okay, cool. I'm glad I picked that one. So
That's cool. I think that's also a good disclaimer too, just in case it wasn't iterated last week or this week, that yeah, what we're doing is not at all like comprehensive of like 100% of everything. It's pretty much saying, hey, like this is like the most common stuff, and that's like good enough for, for your platform for you to then like learn the rest through self-assessment and personal study. Just kind of like the rest of the like boot camp philosophy. All right, we're gonna go through these practice questions. Question one. Can you guys still hear me with the dogs tapping?
yeah,
Yes.
Okay, good. Question one. Which AWS service extracts structured data like tables and forms from PDFs?
Extract.
Any other guesses?
Textract.
Yeah, that's it.
Is that what you said?
Yeah, any
Yeah.
other guesses?
What's it called when you stick two words together like that?
Concat? Like concatenate?
Portmanteau? But also concatenation would make sense.
All right, the answer? Textract. With this one, I'm actually surprised then because I thought I would have said based off of before. Do you guys remember the whole thing with the license plate and scanned document was
The
recognition?
recognition.
I think it's just trying to do the difference between, using extracting, specifically reading text in a photo versus a PDF, like in a form. Because here it's like tables and yeah.
It could be. According to Gemini, if we're all interested, Textract is the purpose-built AWS service for this. While recognition can see text, Textract is designed to understand document structure. In the right, yeah, I mean, that's essentially all it says. Okay,
Yeah.
so I got a little tripped up on that just because of the PDF. Before it said scan document, and to me, oh,
So I think
okay,
it's one of the
it's
things,
a
it looks
PDF.
like recognition can do it, but it turned out to be one of the, since recognition is more broad-based for like finding things in images, when you're specifically looking for structured data, they have a, I don't know, Extract is like the specific model that's good for that.
Yeah, it'd probably work better like exporting it to a database, I would imagine.
I'll say this, I think part of my confusion, and this may have just been me then, I think before when it was referring to the scanned document, right, regardless what was scanned, that scanned document was then, in our example, saved as a PDF. Whereas here, a PDF isn't always a scanned document, right? You can take a Word document and save it as a PDF. So I think that's also an indication of the difference as well. But that could just be my interpretation. So question 2, which layer should you use when pre-trained AI services are not specific enough for your unique business problem? Which layer?
Layer 3.
Yeah, the ML layer.
Perfect. And then remember, there's only one service they have, which is SageMaker for that. Question 3, which AWS service provides access to foundation models from providers like Anthropic and, what is that, A121? Reminds me of Studio 824, which is unrelated. Anyone know which AWS service provides the foundation models?
Bedrock.
Correct. Question 4, a company needs to convert text into speech for a mobile app. Which AWS service should they use?
Poly.
Correct. Polywannacracker. Cracker. Question 5, what is the primary AWS platform for building, training, and deploying custom machine learning models?
SageMaker.
Final answer? Are you thinking?
Wait, hold on. Yeah, let me think for a couple more seconds. What's the platform? I'm going to say SageMaker.
All right, he's doubling down. SageMaker. Just a heads up, just because I ask you doesn't mean you're wrong. It's to make sure you're confident.
I'm not. I just answer. I go. It is what it is. I can only do so much,
Yeah, you're human. I could dig it.